Okay, in this video we're going to be looking at Lesson 6-1, questions 3 through 6. That's going to be found on page 79. So if you turn to that, a couple times during this I'm going to ask you to do some work and pause the video so that you can complete the table on your own. And then from that you can restart the video and check your answers. Okay, so let's look at question number 3. Question number 3 are all these tables. What we're doing is we're applying a transformation of our f of x. Original function. So we'll see we have an original function over here on the left hand side, and what we're going to do is we're going to transform it in some way based off what we originally saw on the front page. So if you look at question number 3, you'll see that on one I'm adding 3 and one I'm multiplying by 3, but both of those happen on the outside of my function, outside the f of x, and so what they do is they change the y values, and so both of these are vertical transformations. Okay, so let's identify what type of vertical transformation we have first. So in A, we have f of x plus 3. So if you refer back to the front page of this packet, page 77, I'm going to replace the 3 with a d, and just to say d equals 3. So anytime I have this set up where f of x plus d, d represents my vertical translation. So this one is going to be specifically going up 3. Remember, anytime you're doing a vertical shift or some kind of transformation vertically, it always will change in the manner it appears in the equation. So if I see plus 3, I will logically move up 3. Okay, I can also have multiplying on the outside, such as b, and so this one relates to the first page by, it's the a times f of x. Okay, and in this case, since a equals 3, we know 3 is greater than 1. So that's going to create a vertical stretch. And whenever we have a stretch or compression, we want to say what factor it is. So it's going to be by a factor of 3. And I know I'm taking up a lot of space on the right hand side, but you might want to write a little bit smaller because I'm going to do the same thing for each row of tables. Okay, so on this one we have a vertical stretch by a factor of 3. That's how you would verbally describe it. So now what we're going to do is we're going to complete the table for these values. So notice that I'm changing the y and not the x. So they kind of pre-started the first table for you. We can see that all of the x's are the same. What's going to happen is all of our y values, or f of x values, are going to be 3 more than what they originally were. So if my input is -8, my new output is going to be 515. That's 512 plus 3 is 515. Okay, for -6, my new output is going to be 219. That's 6 more than 216, or sorry, 3 more than 216. So I'll give you a minute to finish the table. Let's go ahead and look at B. B, I'm going to use the same outputs, so -8, -6, -4, and so on. Okay, and what I'm going to do instead, this time, instead of adding 3, I'm going to multiply the original function, the original f of x value, by 3. So 512 times 3 is going to be 1536. Okay, and then the next one, 216 times 3, is going to be 648. So what I'd like you to do, pause the video, complete the tables, and then restart the videos to see and check your answers. Okay, so here are the answers to question number 3. So if you made any mistakes, go ahead and change it, but you'll notice that the changes just mimic what we did initially in the tables. So let's go ahead and move on to question number 4. So on question 4, you can see that we're doing something slightly different to our equations. We're using the number 2, but the 2 is on the inside of our parentheses. So anytime we're working on the inside of our parentheses, you're going to have some kind of horizontal effect. Okay, so whether you're shifting horizontally or stretching or compressing horizontally. So on problem A, we're multiplying by 2, so that's in the format g of b times x. And in this case, since b equals 2, that's greater than 1. Remember from the front page that the inside is doing the opposite of how it appears. So we're not actually stretching by 2, we're doing a horizontal compression by 2. So when we compress by a factor, we're going to say it's half as wide as it was before. Okay, so even though we're multiplying by 2, our factor is 1/2. Okay, so what happens is that our outputs are not going to change. We're going to get the same vertical height, but we're going to have to use half of the previous x to get to that same position. All right, so our y's are going to be the same, but to get to the same height, we're using half of the x value. So it's going to take -3.5 to get to -100, because -3.5 times 2 gives me the -7, and then it's going to be -2.5, and so on to complete the table. All right, over here on part B, I'm going to see that I'm adding 2. So this is in the form g of x minus c. In this case, to get it to say x plus c, c has to be a negative 2, which means I'm going to move left 2. So that's, again, remember, the inside moves in the opposite direction. So since we're saying plus 2, we're actually going 2 to the left. So again, we want to see the same output, but to get to those outputs, we have to use an x value that's 2 less than what we originally had. So instead of getting to negative 100 by starting with negative 7, we have to start with negative 9, because negative 9 plus 2 gives me the negative 7. Instead of negative 5 give me negative 76, it's going to take negative 7 to produce negative 76. So I want you to pause the video and then complete the tables and then restart the video to check your answers. Okay, so here you can see we have the answers. The y's stayed the same, but the x's were changed in the opposite manner of how it appeared in the equation itself. Okay, so if you had any mistakes, go ahead and make corrections to your mistakes. So now let's move on to question number 5. And you'll notice in question number 5, we're looking at negative signs. So anytime you see a negative sign that's being multiplied out front, you're going to create a reflection. Okay, so in problem A, because the negative side is on the inside, that's going to reflect on A, the negative sign is on the outside, so that's going to reflect vertically over the x-axis. And on B, the negative sign is on the inside, so that's a horizontal reflection, so that goes over the y-axis. So whenever the negative sign is on the outside, what happens is the x's stay the same, but our y's will change signs. So if it was negative, it becomes positive, and anything that was positive becomes negative. Okay, so I want you to, you'll complete that in a second. And then over here on B, the y's will stay the same. So my original output of negative 4, negative 7, positive 56, and so forth. But what happens is the x's will change signs. So then that becomes 4, 2, and then the last one in the table will be negative 16. So go ahead and pause the video and answer this question, complete the table for A and B, and then see if you can come up with an answer of how you can verbally describe the difference between those two tables in question 6. Okay, so here are the tables, so check your answers to make sure that you changed everything correctly. And so on the answer to number 6, I thought of 3 different ways we could describe it. The difference between the two is you could, they reflect over different axes, is one way you just could describe it. Okay, one is a horizontal reflection versus a vertical reflection. And another way you could say is that you change the x's, that you're going to change the x values versus you change the the y values. All right, so there's several ways that you could describe the difference between the two and what the transformation is that is occurring. Okay, so to continue on to question number 7, or the either question 7 or the practice activity on the next page, go ahead and open the next video.